Hi everyone. In this video, we'll see how to connect a device like an ESP32 to digital suite of RunMyProcess using HTTP to send data and visualize it in an interactive application with a map and a real-time dashboard. Let's dive in. This is how the finished application looks. Here, data from a temperature sensor connected to an ESP32 is displayed directly on the map where each marker represents a sensor. Here, we are simulating temperature sensors located in a factory, where you can view its real-time readings, navigate around the map, and explore nearby points for a more comprehensive monitoring experience. We also have a dynamic dashboard that provides an in-depth view of the data. It displays real-time temperature readings from each sensor, ensuring up-to-the-minute monitoring. Additionally, it includes historical graphs that allow you to track trends and changes over time. This combination of real-time and historical data offers a comprehensive overview, making it easier to analyze performance and detect any anomalies in the system. Now that you've seen the final result, let's build it. Let's take a deeper look at how this application is built, exploring the key components that make it work, including the front-end design, the integration of the mapping library, the dynamic JavaScript for the panels and graphs, and how it all connects seamlessly with the backend to display real-time data. The front end of this application was designed using the web modeler in DS of RunMyProcess. It incorporates custom JavaScript for interactivity and leverages a mapping library for the map component. The map allows us to dynamically place markers for each sensor based on their data, and it's highly customizable for various use cases. Additional JavaScript powers the side panels for each sensor, where we display real-time readings, historical graphs, and detailed statistics. This approach gives us full control over the design and behavior of the application. Now, in the Composite APIs section, we will configure the connection with the physical device. Here, we can see the endpoint that will be used by the device. This is the URL where the ESP32 will send its data. This setup ensures that the data sent by the ESP32 is correctly received, processed, and forwarded to the application. By defining the API logic, we can manage the communication flow, handle the incoming data, and integrate it seamlessly with the front end for real-time updates. Here, by the process ID, we are integrating an alert process where, if the variable measured by the sensor exceeds a predefined limit, a text message is sent to the registered phone number. Additionally, these alerts can also be sent via email to notify relevant personnel or trigger commands to physical actuators that provide an immediate solution to the situation. For instance, the system could activate a cooling fan, close a valve, or adjust machinery to address the issue in real time. The next step is configuring the ESP32 to send data to the endpoint. For this example, we're using Visual Studio Code to write and manage the code. In the code, we define the URL of the DS of RunMyProcess endpoint, which acts as the destination for the data, and specify the structure of the JSON payload that will be sent with each reading. The endpoint URL is configured in the HTTP client section of the code, where we set the target for the post requests. Now, let's do a final test. As you can see, the values on the map and the dashboard are updated in real time with the data sent from the ESP32. The map dynamically reflects the sensor readings by updating the markers, while the dashboard displays the new values in graphs and panels, providing an instant and clear visualization of the information. This demonstrates the seamless integration between the ESP32 and DS of RunMyProcess, processing and visualizing data in real time.